All right, continuing on then from page 502, using the exception classes toString and message property. The author says, when the miles per gallon 2 program displays the message you attempt to divide by 0, you actually cannot confirm from the message that the division by 0 was the error. It says, in reality, any exception type generated by a try would be caught by the catch block. So what they're saying is there's two ways that you can print out information. So there's the try. Okay, we could have done this. So where I showed you this before, where we had exception E, and I said write line E dot message, that really calls toString. So they're the same thing. There really is no difference. All right. In most application code, you see it as message. That's why I showed it to you the way I did. So they mentioned both of those, but they're doing exactly the same thing. So here is the E dot message. Again, another you do it here in your book on pages 505 and 506. So if this stuff isn't making sense to you, all right, then, all right, go through the examples that are in the book. All right, jumping up to 507, catching multiple exceptions. I already mentioned this to you. Okay, if I'm writing a complex program, think about this. All right, we have not gone over files yet. That's the last chapter of the book. But let's say we had. Okay, so you're writing a book where you are reading in information from a file and you're throwing it into an array, as an example. Well, what can go wrong? Well, you might not have the right file name in there, so it could be some kind of an I/O exception. You could try to put something into an invalid array location, which is an index out of range location. All right. You could have a format problem, which would be a format exception. So those are just three possible exceptions you could have. So your program can go and put in as many of these catch blocks as you want to. All right. So this one, the divide by 0, would probably be for that line right there. This one would probably be for the line that's right there. All right. Sometimes you don't have much choice. You have to use try-catch, even if it slows down the program. To totally idiot-proof it, that might be the only thing you can do. And if it's a difference between a program not working and not working like a little slower, you'll typically settle for it working but working a little slower. It's like if you've ever heard that, I've heard this on television. What is it, like 70, the last number I heard was like 73% of people that were polled said that they don't mind it taking a little longer for them to get on a plane if the people who are the TSA agents who are checking are doing a good job of checking. All right. I don't know if you heard that. There was a thing on the news that last week, for some reason, that something malfunctioned in one of the things for like 10 minutes. And they had like 6 people that got through. And they said they could have had anything on them, bombs, guns, and they wouldn't have known. Luckily they caught it, and they did check these people out once they landed. Okay? That's the good news. The bad news is, what if they blew something up while the plane was in the air? That wouldn't have helped them much. All right? That is mission critical software that didn't work. That is not fault tolerant. I'm sorry. If you tell me, yeah, I could be on a plane, but there's only like a 1% chance, especially if I'm a frequent flyer, okay? At a job I used to have, they'd fly me out every month. For one job I had, they flew me out to New Jersey. For another one I had, they flew me out to Denver, Colorado. If I would have heard stuff like that, I would have been, you know what? I'll spend a day and I'll drive myself. At least that way, if somebody's coming at me, I have the ability, hopefully, to get the hell out of the way. But if I'm in a plane and something's coming at me or whatever, I'm kind of stuck where I am. All right. Jumped up all the way to page 510 here because the rest of them are just examples of running this program. Okay. Both of these are on the test, or at least dead code is. If code is unreachable, remember this? This is kind of a little thing for you that if we did this, switch on number, and we put in here case 1, and we've got right line 1, break. Everybody remember that kind of stuff? All right. You may or may not have ever done this, but if I come out after this and I write in here, read line. Technically, I could never hit that code because it already did the break, correct? If I try doing that, usually I'm going to get an error message, and it'll say right in the error window, unreachable code. And it means just that. It's code you cannot reach. Programmers oftentimes refer to that as dead code. All right? It's literally code that there's no way that it can execute. So you're like, well, then why would you even have it there? That's a good question. All right? But there is dead code that's out there. And they give you their example, okay? Again, another on page 511. Another you do it on 511 and 512. Notice there's not much code that you're putting in if you key these in. All right? All right, let's jump up to 512 and look. And what they're doing now, examining the structure of the try-parse statement. The try-parse is something that we talked about in an earlier chapter. All right? But the author is saying here, in chapter 8, you learn how to use it. And they show you a typical type of try-parse. That's very similar to what I showed you before. All right? It says this statement uses the int version of try-parse. There's an int, there's a double, there's some other ones. All right? The first argument is the string you want to convert. So input string. That's something where we read a value in using a read line. All right? If we are able to successfully convert it or parse it, we want to throw it into number. And what's good is now every one of you in here knows what out means, because we talked about that in an earlier chapter. That means that out probably previously didn't have a value or didn't have to. All right. So this says I've got a string where I've read something in called input string. Attempt to take that input string, try to parse it or convert it into an integer. If you're successful, put it into number. If it's not successful, there's the not sign up there, right here. So if it didn't work, then set it to some default value. Does that sound familiar to you? Isn't that kind of what we just did? But we used the question mark colon operator. So we were doing a similar type of thing in the class thing that you just went over. All right? It says, suppose that no try-parse method existed to convert a string to an integer safely. It says, using what you've learned so far, you could now write your own method. And I'm not going to go through this. They do show it to you on page 513. But what's important for you to realize is, yeah, you can write your own. Don't you think this in the background? This is what try-parse does, is something like this. There's no magical code. Try and parse don't mean anything special to the system. When you put a try-parse statement in there, it's got to call some other code to do something. So it's calling something like this, is what the authors say. Finally block, we've gone over already. This is on the test. Notice, and the finally block executes whether or not the try block succeeds. So whether the try block, all of it works and there's no catch, or whether there's a problem in the try block and the catch executes, either way, if you put a finally, which must come at the end and which is optional, all right, the finally always runs. Again, they show an example here, and usually you use the finally for what are referred to as housekeeping operations. Closing a file, closing a database connection, all right, something. Maybe you've got some kind of a message you want to print out to the user, whether the try succeeds or the try fails. You know, thanks for playing our game, or whatever it happens to be. You can put that all into a finally block. So again, it says, take that from the previous page here on the bottom of page 515. It says, therefore, it seems as though the statements after the catch block always execute. So there's no need to place any statements within the finally block. However, the stuff after the catch block might never execute for two reasons. First, something may have happened where it's such a bad error that in the catch you tell the program to end. All right? Or, the exception for which it says for which you did not plan might occur, which means you didn't catch something that you should have caught. And that's what's explained here. But the idea is the stuff in the finally always executes no matter what. That's the key takeaway right here. Always executes. That's what the author is trying to show here. Okay? And it says here, right up, I'm on page 516, the code in the finally block executes no matter what happens. All right? Whether the try ends normally or abnormally. Even if it ends abnormally and there's a bad catch in there. In other words, the catch doesn't catch anything. All right, you haven't written a certain catch. All right. Now notice in this little pin that they put here, a little paper clip on the bottom of 516, Java, Visual Basic, and C# all provide try and catch blocks. So I'm not going to lie to you. When we get to the point in Java a year from now, there's a chapter in the book on exception handling. That's going to be part of a class period because it's handled exactly the same in here as it is in Java as it is here. So it'll be review. There's not going to be enough time in 40 days next semester. It's kind of like we're rushing through this book. Java might even seem more like that because we're going to be writing at least one Java program for every chapter that we go over the book. We're going to write one as a class. I'll write one and then I'll be assigning one or two. All right. Handling exceptions thrown from outside methods on starting on 517 and going all the way through page 520. It says, an advantage of using object-oriented exception handling techniques is the ability to deal with exceptions appropriately as you decide to handle them. The key thing right there is as you decide to handle them. If you don't put try-catch in there and something bad happens, the program takes over. Remember we talked about explicit versus implicit? If you don't explicitly put in your own code to handle it, the program implicitly handles it for you. And it handles it in the most harsh way possible. It says, sorry, you're done. And it just stops the program. But by you using try-catch, you can have some control over what happens. So they give an example there. If you do this, you know this already. Now you know what happens if we're asked to do this and I put in something non-numeric and it doesn't work, I get a format exception. It was expecting a whole number within a certain range. I gave it either a number out of range or I gave it a non-whole number. So the author mentions here on the bottom of 517, very bottom of the page, it goes on to the next page. When you design classes containing methods that have statements that might throw exceptions, you most frequently should create methods so that they throw the exception but do not handle it. All right. In other words, maybe your code isn't built in with the smarts that it can handle it. Or think about it this way. Let's say I've got a game. All right. So let's say I've written a game in C#. And let's say there's some kind of a maze in it. Okay? And you go through this maze and you've got something shooting things at you, whatever it happens to be. They're shooting bullets at you. All right? So what can happen? Well, if I'm trying to go through this maze, I can possibly fall off a cliff. I'm trying to go through this maze and maybe I keep trying to go to the right. There is no more right. So boom, I fall off and I die. All right? Maybe a bullet hits me and I die. So there's different things that can happen. So what I might decide to do is I might decide to write a generic routine that's going to handle any kind of error, any place in the program, no matter where it happens. So if that error happens, I call that routine. Does that make sense? It's kind of like, when you have somebody who's designated, let's say, it's like David Markowitz who was in here, the counselor. All right. His job is to sit and work with anyone who's having any kind of problems or needs help with any kind of issue. All right. So it's like, I got this problem, send it to David. I got this problem, send it. It's not the same problem. Doesn't matter. He's our go-to person type of a thing. You sometimes do the same kind of thing that when you were writing code like this. All right. And that's what the author's mentioning on the bottom of the page and on the top of the next page. So this, when you write code, you are in charge of handling it when something goes wrong. And when something goes wrong, notice I didn't say if, because something will go wrong. Sooner or later, something will go wrong. But you are in charge of handling it, because if you wrote it, you can explicitly say what you want to have happen if something goes wrong. And if you don't explicitly do that, then as you know now, the system will implicitly handle it for you. And again, by and large, it handles it in the most harsh way possible. It says, you're done. It just closes the program down. All right. Let's jump up to page 521. This is what I'd mentioned to you before, this tracing exceptions through what's called the call stack. So if I had a program that did this, and don't worry about what these things are, we don't care. But we've got a method A that calls method B. Method B calls method C. Method C throws an exception. It's kind of like a hierarchy, kind of like a class hierarchy that we had. You've done things like this. You've had main call other routines. Sometimes those other routines call other routines. All right? But what the author is saying here is A calls B, B calls C. C throws an exception. By default, the program looks and says, oh, there's an exception here. Do we handle it in C? Is it handled right in the routine where there was a problem? Okay, no. So then it jumps up to the one that called that. And it said, well, C was called by B. Okay, does B handle that? No. Okay, then method A called method B. And then it comes up and it says, did method A handle that? No. That means that it's going to blow up because no one's handled it. As you're working your way up what's called the call stack, you're doing what's called propagating an exception. And we didn't go over it last semester, but guess what? The same thing happens on a web page when you put JavaScript in there to interact with it. I might have a routine that calls a routine that calls a routine that maybe throws an exception. So again, they used A, B, and C, but if you look at it, I've got method 1. Method 1 calls method 2. Method 2 calls method 3. Let's leave it there like they did in the book. Method 3 throws an exception. All right, whether there's a try-catch block in there or not, method 3 throws an exception. So the system looks and it says, okay, do you have anything inside of method 3 that handles that exception? If they find it, it handles it right there. If it doesn't find it, it says, okay, number 2 called number 3, does that have anything to handle the exception? If it does, it stops right there and handles it. But if it doesn't find anything, it says, okay. It was called by method 1. Did it have anything? And if it does, it handles it. If it doesn't, it goes up to the top. And this isn't something I wrote, so the system will handle it. And again, 99.999 times out of 100, that means the program will terminate. That's actually a good thing. Having it terminate is much better than having it like go into an infinite loop where you have no control over it. You have to shut the system down. You wouldn't want that to happen. So in that case, it would actually be better that the program would just stop right there. But that's what they're showing here. That's exactly what's going on. And again, that's referred to as propagating the exception. That may or may not be on the test. I really and truly don't remember. So they give you a case study of using this stack trace. And they're showing you what will happen when you do it. All right? The stack trace in here isn't nearly as refined as it is in Java. So we'll look at it in more depth and breadth of coverage in Java. All right, I'm jumping all the way up to page 525 on the bottom of the page, creating your own exception classes. Notice, C# provides more than 100 different exceptions, but most of them are fairly general in nature. So if you want your own exception, you can write it. And I think the example that they use in here is they say that, for example, if you were writing a payroll application, again, something similar, something that we've done in here, and we wanted to be able to write our own exception so that rather than handling it the way that we've been handling it, if you put in a number that's less than the smallest or more than the greatest, we handle it with exceptions. We could write our own exceptions to do that. All right, and that's what they start on 525. When you do this, this is your own exception. So you would create a class. The name of the class would be negative balance exception. It's not mandatory when you write your own exception that you put the word exception in it, but it's standard procedure. So if somebody sees the word exception, they that's error handling code. All right. So even though you don't have to do that, you should get into the idea when you write your own exception, putting exception at the end of it. Don't call it exception, but something exception or something exception. Remember what this means from the last chapter? Inherits from. So this means that negative balance exception is an exception. You should know that by now. That's what we went over in the last chapter. All right? So if this happens, what's it going to do? It's going to literally create this message that says bank balance is negative. And then it's got this. Remember this from the last test? This says call the parent, so call exception class. So the exception class is going to print out there bank balance is negative. It looks a little funky. It's like, why do you do that? Because that's the way it's done. And it's done the exact same way in Java. All right? Except in Java, you'd be using the word extends here, and you'd be using the word super here. Other than that, it works the same way. Again, another code snippet that shows this on 527 and 528. All right, believe it or not, last thing in the chapter on 529 and 530 and 531 is rethrowing an exception. It says when you write a method that catches an exception, your method does not have to handle it. Instead, you might want to rethrow to the method that called your exception. Kind of similar to what I just mentioned to you, but take a look at what they show here on the bottom of the page. This is the bottom of 529. Method, main calls method A. Method A calls method B. Method B calls method C. Method C throws an exception. All right? So it says that C doesn't handle it, so it goes up to B. Okay? So what can happen is, what B can do instead of handling it is it can automatically throw it back to A. All right? And A can say, I'm not handling it either. It can throw it back to main. Now this is an example. This is not necessarily the way you would do it, but it is a way that you could do it. And they show that in an executing program here on page 530. Okay? And then they show you the output of this. So trace through it. And then take a look at the output that's on the top of page 531. All right? All right, let's take a minute here and go over at the end of our chapter, as we do, let's go over the review that's in your book, the review questions on pages 533, 534, 535, and 536, and 537. Long enough. All right. All right, so here's your review questions. Number one, I think this is taken almost directly from the test. So this might be one of those fill in the blank questions. An error condition or unexpected behavior is known as an exception. So number one is A. Number 2, which of the following is not treated as an exception? It's B. You attempted to execute a C# program, but you have no compiler. That's so far beyond. All right? That's like saying, you're going out someplace and you have to build a fire. You have no matches, there is no wood, there's nothing that would burn. That's beyond your control. All right? Sometimes that just happens. So number 2 is B. Number 3, most exceptions you will use derive from which classes? The answer is B. The exception class, the system exception class, or the application exception class. So number 3 is B. Number 4, exception objects can be C, generated automatically by C# or created by a program. So the answer to number 4 is C, both of these. Number 5, when a program creates an exception object, you A. Notice it's can handle it. It's not must. You can handle it by yourself. Again, if you don't, the system will. It would have been better there if they would have said, you can explicitly handle it. All right, so that's number 5 is B. Number 6, if you do not use object-oriented techniques, D, you still can manage your situations. That's what we've done up till this point. We haven't used try-catch before this chapter, and there's been, you can almost idiot-proof a program without try-catch. So number 6 is D. Number 7, also D. In object-oriented terminology, you try a procedure that may or may not complete correctly. So number 7 is also D, try. Number 8, in object-oriented terminology, a method that detects an error throws an exception. So number 8 is A. Number 9, when you write a block of code in which something can go wrong and you want to throw an exception, if it does, you place the code in a try block. So the try is the code that can potentially fail. So number 9 is D, try. Number 10, a catch block executes when its try block, C, throws an exception of that particular type. So number 10 is C. Number 11, all right, which of the following will catch any exception object? It's this one. Exception is the most generic object there is. So 11 is B. Number 12, which of the following is valid within a catch block? All right. And it's A and B as far as 2 of these. I don't know why they said that, but it's A and B. All right, so 12 is D, and it's A or it's B. It's doing the same thing, but it's either using the toString or using the message. Number 13, you can place D, any number of statements within a try block. So number 13 is D. Number 14, how many catch blocks might follow a try block? Now, this looks like it's an error because it says any number including 0. If you remember before I put that try block in there and I didn't have a catch yet and it gave me an error, you can have a try without a catch. But if you have a try without a catch, then you must have a finally. So you could have a try, 0 or more catches, but if the number of catches is 0, you must have a finally. If you do a try and you have 1 or more catches, you can have a finally, but you don't need a finally. All right? So number 14 is D. Number 15. All right, they give you an example here, and it says, what is the value when the code completes? Well, if x is greater than 10, throw this new exception. All right? And If it is greater than 10, okay, you're going to throw that. Otherwise, a is 0 plus plus a. I'm not sure if that answer is right or not. It says because x is greater than 10, the exception is, oh, you're right, they're right. Is 99 greater than 10? Last time I checked it was, so it will throw that exception. That's why the answer is correct, is C. Even though you can never go back to this. Once it throws the exception, you get out of the try block, you can't come back to it. Number 16, considering the following catch blocks. B has been initialized to 0. If a divide by 0 exception occurs in a try block just before the catch block, what is the value of B when it completes? Right. And the answer is 1. Initialized to 0 if it occurs in a try block just before the catch block. What is the value? Okay, because in either case, it's going to throw either one of these exceptions. What does it do? It adds 1 to B, which was 0, so it's now 1. All right, so 16 is B, 1. 17, consider the following catch blocks. If the variable C has been initialized to 0, if an index out of range occurs just before the catch block, what is the value when it completes? Okay, and it's got 2 there, so let's see. What's that? Yes, so right here, it would add 1 to C, which would make it from 0 to 1, but the finally always runs, so it would go from 1 to 2. So the answer is C, 2. Number 18, if your program throws an index out of range exception and the only available catch block catches an exception, all right, so if exception is the only one in there, that one will execute. All right, if that's the only one that you've put in there. So the answer is B. Number 19, when you design your own exception classes that might cause exceptions and other classes will use your classes as clients, you should usually create your own methods to throw exceptions but not handle them. That's kind of what we looked at right at the end of the chapter. So 19 is B. 20, when you create an exception subclass of your own, you should extend D, the exception class. That's like object. The exception class is at the top of everything. All right. Any of those need repeated? All right, then if you would, please take out your test review, which is the study guide here. I'll have to find where I've got the filled out one. We'll do this. We'll take another break. We'll come back, and I'm going to hand out that example that I showed you before. All right, and you don't have to key that in or anything. All right, here they are. Number 1, how many C# defined exception classes are there? We just saw that. There are more than 100. Again, if you're going to study something, please study these guides before your test. Okay? Tomorrow is what? Tomorrow's Friday. So tomorrow we're going to go over 2 examples. My goal is to get done with both of those examples by 10 o'clock. You'll have your assignment, and you can work on that for 2 hours after that. Monday, next week, Monday, which is the, I don't know, 13th, the 6th, I think. Monday, you're going to take the written test for Chapter 11 first thing. All right? Then we're going to do just what we did today. We're going to go over Chapter 12. And I'll have an example for you. And then Tuesday of next week, all right, we'll go over a couple more examples. Wednesday and Thursday are going to be labs, but what we have to sneak into Wednesday and Thursday, and we'll probably do it Thursday, are 2 different things. First, I want to go over with you, and most of you in here, not all of you yet, but most of you have now turned in a resume to me. There's still a couple of you who have not. But I want to show you a generic way, kind of with all of you who have sent me something, I've kind of written back your resume. They all kind of look the same. And I want to show you that. So if you've got no experience writing a resume, it'll at least give you like a template or something you can use. That's the first thing. Second thing, you're probably not going to like this, but we're doing it anyway. And that is, with 9 of you in here, you're each going to get 2 or 3 machines. Supposedly now, on every machine that's in here, these 24, and I think these 2, now have Visual Studio on them. And I'm going to ask that you get in there and try it on that Thursday, because I don't want there to be any surprises when we bring those students in here a week from tomorrow. So I want us to try every machine, because if there's a problem, that'll give John, the lab assistant, time in the afternoon to try to fix it. All right? And Friday, of course, next week, a week from tomorrow, that's when we'll have the students from Lewis and Clark coming in here all day. I guess I am giving the lectures, but I will give each one of you a hard copy of everything we're doing. They're going to get the completed package, so to speak. They're going to be in here from 8:30 till 12. All right? And what I've been told, no jokes, what I've been told is work their asses. In other words, don't work for 30 minutes, give them a little 10-minute break, work for 30 more minutes, give them a break. No. We're going to have maybe one break in there. That's probably going to be it. They want me to give them as much stuff as they possibly can, because these are 33 potential students to come to this institution and to this program. And if he doesn't mind me saying so, and I've already done it, so I guess not to embarrass him, but Colin, you went through the thing at Lewis and Clark, correct? So he knows what it's about. All right? But these are people that by and large can actually get some kind of a certification in what they've done, and they're going to be coming in here, and they'll be, I'm not going to say the leaders, but probably more than most of you in here, because they have experience. Now, what they're doing, they have 2 semesters, I believe, that they go through, not 2 years, but I think it's 2 semesters. The first semester, it sounds like everything they do is Python. They know more Python than I do. Okay, I'm not ashamed to say that. The second semester, they go through other languages. All right, but they do very little with web development, and they do very little, really nothing with C#. And that's why they're going to have the C# project. Okay, and just so you see this, because I created this the other day, and when you say, wow, that's not real good, yeah, because I didn't spend much time on it. No excuses, I just didn't. But this is that Magic 8 Ball. You've seen that, so I'm not going to bring that up. And I made this. So this is, it's got a slideshow that's, I got to change the time on it, but this is taken right from their site. These are their pictures, and this is text from their site. Well, you can't read that very well. We can blow it up, but just so you see it. Okay, they're going to learn how to build that. I'm going to give them all the code for it, or all the verbiage. There's an about page that's got some more general information. These are all their different programs. And then finally, I created a contact page. All right, and this even goes back to their Facebook page. All right, and is it great? Hell no. It's functional, but what I want you to see is if you look at the home page here, can you see how it's responsive? All right, so that one is, and I purposely did it this way. So is this one. But the last one is purposely not responsive. So I can show them what happens when you have a non-responsive page. You go, no, it's responsive. No, it's not. Look at how stuff cuts off. All right. So that's what we're going to talk to them about. And I don't know how much experience you have with it, Colin, but at least it'll be a little bit of an introduction to you so you can see the kind of stuff. All right. And it's going to be interesting in fall because this summer, one of the things I'm charged with, I've already told you this. You're going to get really sick of this. But I'm building a site, and my future son-in-law is trying to convert me into a hockey fan. All right, he's doing his best. It's not working real well, but he's trying anyway. All right, so what we're going to be doing is we're going to be creating a site for the St. Louis Blues. Not really, we're not going to give it to them or anything, but we're going to create that. And I'm going to create the same site, so you could actually be doing it twice. But we're going to do it at the beginning of the ASP.NET if you take both classes. We're going to be doing it first before we get into ASP.NET. We're going to be creating the website the first week or two. and a lot more time than that than in the other class. Then we're going to take it and we're going to bootstrap it and we're going to put it into ASP.NET. We're going to hook up a database to it. We're going to have a little store there where you're able to buy things, etc. That's all the stuff that we're going to be doing next semester. All right. Now, we won't get into nearly that detail in the class that you had last semester, but I think that one of the things I learned from teaching that class last semester is we should have been building a site as a class for the entire semester, and we didn't do that. So we're going to do that. What I did with you last semester, if you remember, is we built one from out of the book. All right. But I gave you all that code. I'm not going to do that with people next semester. We're going to build it. They're going to be responsible as we're building it for turning it in and making it work. So will you. All right. The book that we use next semester, it's a thick mother. It is thick. And it's a book that's from a company called Burok, and they write really good books. All right. And I don't say that because they've asked me to write one of their books for them, which they have. All right. But they are just a really good company. But what they do is the way that their books work is on the left-hand side, you get a bunch of text. And on the right-hand side, you get either code or descriptions and explanations of the text that was over here. That's why they're big books. The book you're going to use next semester is upwards of, I think, 800 pages. The good news is their books aren't expensive. I think that book is under 50 bucks. All right? And some of these books, this was like over 100, correct? That's a rip. I'm sorry. It's not that good. She writes a good book. It's not that good. All right? It's really not. Okay. All right. So, sorry, that was a long interlude, but that was number 1. Number 2, you can circle these or do whatever you want to do. Compiler errors are not considered to be exceptions. You can deliberately generate a system exception. That's what I did when I divided by 0. You can place any number of exceptions in a try-catch block. So please listen to this. Don't look at me. Don't even look up on the screen, but listen to this. Look at your screen. That's 3 different questions on your test. Right there. Now, it may be worded totally differently, but that's 3 questions on your test. So don't get those wrong. All right? Everybody has those? Are not, can, and can. Number 3. All C exceptions are members of the exception class. I drew that on the board for you before, where we had exceptions, and then under it we had application exception and system exception. The parent of exception is object, because object is the top of the ladder, so to speak. So all exceptions are members of the exception class. The exception class is a descendant of the object class. I don't know if that's 1 question or 2, but it's on the test. Number 4. They give you some examples in here, and it says, if you get this kind of problem, what kind of an exception is it? So please look on the screen here. It would have been better off to do it like this. I don't know. It would have been better off to do it like this. So in other words, this one right here is a system array type mismatch. This one right here is a system data operation aborted. This one right here is a system invalid operation exception. So if it makes it, I'm trying to make it easier for you, not harder. So if I am making it harder, sorry. But does that make more sense? To look at it like that? Maybe it does, maybe it doesn't. It's a pretty safe bet that if you've got an array exception, it's going to either have the word array in it or the word index. Does that make sense to everybody? In here, if it's going to be aborted, there's probably a pretty good chance the word aborted will be in the exception. The last one is a little bit more generic. We'll be done. It might take till close to 10:15 to finish this, but we will finish this, and that's it for. I'm going to pass out that example. All right, but we'll take a break, but you'll still have at least an hour to work today. Everybody has these 3? All right. This is taken right from the test. Again, it's either a fill in the blank or it's a multiple choice. I don't remember, but you are asked, what is robustness? Everybody learns this stuff differently, and I realize that when you're doing your written test, it's what I like to call store and dump. You're asked to store it in your brain, then dump it out on a piece of paper. All right? And yeah, that's not the best way to learn. Hands-on is much better, but this is the way this is half your grade almost. All right? Or half of whatever, the percentage of testing is. All right, the degree to which a system is resilient to stress and able to maintain correct functioning. Now, if I'm going through this too fast and you don't get a chance to put it, this is right from out of the book. Number 6, an infrequent, there's a mistake there if you look on the screen here, that should say event, not even fires. It should say event fires. An infrequent C-sharp event fires less than, the answer is 30% of the time. This sounds to me like one that would be a multiple choice, but I don't remember. So 6 is 30%. 7, a little longer. What's a try block? What's a catch block? What's a finally block? What's an unreachable block? All right, and I'm going to put this in here. I see I spelled that wrong. I'm going to put in here also known as dead code. So, again, let's do what we did before. Make it a little smaller so you can see all of it there. That's everything. Don't know how to make that disappear. There we go. I do think there's something on the test that asks about dead code. I don't remember what it is, though. Number 8, the C exception class overrides the toString method. The toString method also contains the message property. I don't know if that's one question. My guess is that's 2 questions on the test. So know the difference between toString for that and message. ToString is a method. You know that because it has what at the end of it? What does ToString have at the end of it? Parentheses. And since message does not, it's a property. Attribute, data, whatever you want to call it. So number 8 is ToString for the first one and message for the second one. Number 9, try parse is the answer. The try parse method is used to convert string data to another data type. Int.tryparse, double.tryparse, etc. So number 9 is try parse. And if you're ever using it, remember it is case sensitive. Since it is a method, technically should look like that. All right, with the parens on the end. We just talked about that. All right, number 10. You terminate that, and technically that is the right answer, but really it's system.environment.exit. But I think you can do it since we're already including system. I think it'll work without that. I always put it in anyway. So it doesn't matter. I think for the test, I think they just say environment.exit. But really it's system.environment.exit. So even though I put that in there, technically it's this. Since there's parens there, you have to put a number in there. And typically the number you put in there is 0 if it's normal program termination. All right. That's number 10, environment.exit. Number 11. You have problems with a file, it's an I/O exception. What does I/O stand for? Input, output. Input would be a read operation, output would typically be a write operation. But it's an I/O exception. You see a lot of that stuff with I/O in it. So again, number 11, I/O exception. If you ever throw one, it is again case sensitive. The I, the O, and the E are all uppercase. Number 12 is kind of long. Let's do the same thing that I was doing before. So let me do this. Okay, stack trace. You'll see it all just a second. And then finally, how do you create your own exceptions? There we go. Hope that should be big enough that you can read it, right? Sorry, I know that's a little bigger. Again, at least 4 different questions on the test. Since your test has 40 questions, that's 10% of your test right on the screen. And please, we talked about this last class, especially if you're doing the last page and you're doing those definitions and you can't figure one out, look at earlier places in the test. It's probably already been asked. All right, you can pull the wordage out of there and just put it in and map it up with what's in there for those definitions. When we get to, there's 4 more. The last one is the definitions. When we get to the definitions, again, when you're done with the definitions, take a break. All right, and we'll start up again sometime around 10:30, but I'm only going to go about 15 minutes. Give you all the handout. This is the example that I showed you before. And it's leaning even more than it had been. All right, everybody has those? All right, number 13. Rather than writing a method, to catch an exception, you may choose to rethrow. So number should be 13, but rethrow. All right, number 14, I'll just leave it the way it is. I don't think that's too much. We could even blow that up. So an exception is any error condition or unexpected behavior in an executing program. Exception handling are the OO techniques. Remember that? That was from the first page, the second page of the chapter when we started going over it today. First page had the objectives, and then right after that they had this. They defined an exception, and they defined exception handling. Okay, number 15. Again, 2 more questions on the test. What is a fault-tolerant app? They're designed to continue to operate when some part of the system fails. What is mission critical? It's any process crucial to an organization. The mistake a lot of organizations make is if they'd see this, they'd say everything we have here is mission critical. No, it's not. Not to be funny, if I was leaving here tonight and I got run over and died, there wouldn't be class tomorrow, my guess would be, but there would be Monday. I'm not, technically, I'm not mission critical. They'd find somebody to replace me. It wouldn't be me. The class would be taught differently, okay? But basically mission critical, I gave you the example with a race car before, but it's, that the problem a lot of companies have is they think everything in the company is mission critical, and no, it's not. Just a second, I'll go to the last page. The last page again, the last page is the definitions, okay? What I'm going to do is whenever I turn to that last page, which will be in 1 or 2 minutes, 15 minutes from the time I turn there, then I'm going to go over the handout that I just gave you. See what I'm saying? So try to get a break in during that time. Hopefully you can, in 5 minutes or so, you can type in those 9 terms, all right, and then get a 10-minute break. Everybody has those? All right, let's go to the last page. And like I said, I'm going to have to shrink this down if we want to be able to see it all on the same page. That's about as small as I can make it. Is that still big enough that you can all read that okay? Ivy, you can see that okay? Okay, all right. I don't put a lot of trickery in these things. In other words, I don't change the order. That's probably the order in which they're going to be on the test. I don't have the time to do that. And I think instructors who teach that way and purposely try to trick you and whatever, they shouldn't be teaching a subject like this. Maybe they should teach a psych class or a philosophy class or whatever. Right? So get this done and get your break in. And then at about 10:20, let's make it 10:22. That's 15 minutes from right now. At 10:22, I will go over the handout that I just gave you. So your last hands-on test in here, which will be, like I said, in about a month, but it'll be on chapters 11, 12, 13, and 14. Just so you know, don't cry over this. Your last test will be one problem. Your last test will be GUI because the next chapter is all on GUI. And it's on a lot of controls we haven't talked about yet. Radio buttons, list boxes, check boxes, etc. Picture boxes. Those will be on your test. So I'll have a picture of what it should look like when it runs and an example of a run. Chapter 13. Anybody remember last semester when we started to do things and we talked about event handling and how JavaScript would be able to listen for this and listen for that? Chapter 13 is on how C# does event handling. You already know some of it. Click event for a button or click event for a menu. And then chapter 14, the last chapter, is on files. So you'll have to build a GUI for your last program. It'll have to have try catches in it, and it'll have to write output to a file and or read input from a file. That'll be the last hands-on that you have in here. Okay? We're off the week of the 13th through the 17th. When you come back that next week, we're going to go over those last 2 chapters, chapters 13 and 14. All right? And then that Tuesday, I think, the next Tuesday, which is, like I said, into April already, that's when we'll have the last hands-on test. So if you got this done, please take a break. Again, 12 minutes. In 12 minutes, we're going to start up, and I'm going to go over for about 10 to 15 minutes the handout I gave you. You'll have at least an hour today to work. I'm going to give those all back too. Yeah, set up about 11 minutes.